We're recording. So I'm recording. So this is the midterm from 2017. Some tips. Fill out the first page properly. Okay? Invariably, people screw this up. So please, in the very least, write your student number properly. Right? Your student number will uniquely identify you. So as long as that is there, I can identify you. Also, your user ID. Remember, I'm going to have to enter your grade into a spreadsheet, which means I have to find you. And there's 1,000 of you. Right? So don't make it harder for us to input your grade. Some of you may have an English name and a non-English name. Please use the name that you've given the university. The university has some name for you on record. Use that one. Because again, I have to match you in the class list. So just be aware of that. Let's just read through these instructions. So you'll have at least read through the instructions once. Don't start writing your test until you're told to start writing your test. Okay? Big deal. People try to cheat. Just relax. Try a mantra. Try to calm yourself down. The midterm consists of 3 questions on 6 pages. Count the pages, right? If you're missing a page, that's on you, right? Because any student could just rip out a page and not do the question that they felt that they couldn't do. So count the pages. I've never in my life encountered a student who was missing a page, but just be careful, right? Ensure that all the pages are there. You may assume all relevant import statements have been performed. Okay, so don't ever throw an error like, oh, you didn't call the library. Assume that all libraries have been called. No error checking is required. Okay, so all user input coming to your functions is valid input. If we need space for rough work, just use the back of the page. If part of that rough work contains a solution, write where we can find your solution. Right, so if you run out of room on question 2, you can say something at the bottom of that page, continued on back of page 2. Right, but you have to direct us to where the rest of your solution is, right? Or we'll just stop when we see it stopped. You can use a pencil. I imagine most of you still are using pencils. That will change. I guarantee you'll all be on pen by the end of your university career. Happens to all of us. We can't regrade your test for obvious reasons if it's written in pencil, because you can erase stuff and put other stuff there. So you can do most of the work in pencil. Just write your last answer in pen. If there's a box that says write your answer in here, write that in pen. Right, and then you can get your stuff regraded if we marked it wrong. So assume, okay, so in the last class I made a bunch of mistakes because I didn't read the question properly. Right, so let's read the question properly, right? Because that is a big deal. So assume each of the pieces of code below is, oh, let me just show you something at the end here. Oh, it's not there. Never mind. Abort. Assume each of the pieces of code below is being entered into the Python console. In each space, write what would be displayed on the console, if anything. If a line of code would not cause anything to be displayed, leave a space blank. If the code would cause an error, write error and provide a brief explanation as to what that error would be, and leave any later spaces in that sub-question blank. Part 1. Oh, these are the solutions. So maybe I should open the questions. Okay, this is the different, well, who cares? 2016. For each of the following code fragments, draw a line through any code that is not executed. Oh, okay. So everyone's savvy with that. So part A, we need to cross out all code that isn't executed. Everything's executed in part A. This is a very confusing question, right? Because everything's executed. How else are the Boolean statements evaluated? Yeah.
Maybe if it's like the first part of an and, it doesn't look good. I meant the first.
Okay. I think maybe you have it. Yeah. So don't forget about short circuiting, right? So I think maybe that's what this question means. So okay. So the first line, does that get executed or not? Yeah, it has to get executed. X gets assigned 3. The second line, Y gets assigned 4. That's executed. Okay, so condition 1, that's the first opportunity for something to not execute, right? So is X greater than 3? No. Okay, so this goes to, okay, so there's a bunch of things that don't execute here. If this is false, then we don't bother looking at this. So that gets crossed out. And we also don't bother looking at this. Oh, no. We do look at that. So this this gets crossed out in this line. Okay, condition 2, is X greater than 3? No. So then I have to cross everything out here. Okay. Condition 3, is x greater than 3? No. Or y is 3? No. And x is less than or equal to 4? True. So in condition 3, everything got executed, so nothing is crossed out. Let me just look at the solution. What? Did I say something wrong? X. Oh, sorry, you are correct. Yeah. So this evaluated to false. So this doesn't get x. This gets crossed out. Thank you. Okay, so let's check to see if this is correct or not. Okay, so that seems. Is this what we answered? Yeah. Great. Don't look ahead. Don't cheat. The solutions are online as well, so don't stress out about copying them. Okay, so part B, same game here. We have to cross out all code that doesn't get executed. So licensed is equal to true. So if licensed, okay, so we're in that if statement. So for sure, we have to evaluate this. Is the age less than 16? No. Okay, so we should cross out this. That doesn't get executed. This does get executed, so we don't cross it out. So this gets crossed out because that's the else branch of the if that we've already entered. Okay, but these are consecutive if statements, so we still have to look at this. The age is not less than 16, so we don't print this, so that gets crossed out. Elif not licensed, well, we are licensed in this case, so this gets crossed out, else this prints. Okay, so the only two things that we did not cross out are this and this. Everything else gets crossed. Great. Okay. Right, questions. Assume each of the pieces of code below is being entered into the Python console. Each sub-question is independent of the others. Right, so don't use the values from part A and part B. Right, assume that the console has been exited and re-entered. Oh, that's one thing I forgot to tell you about files. So I listened to the lectures, and I think I gave you the impression that the only reason we use files is because we want to be able to load something huge into RAM. That's not the only reason we use files. The other reason we use files is because files are persistent, which means, so stuff that's in your RAM, if you turn off your computer, it disappears. Right? The stuff on your hard disk stays on your hard disk when you turn off your computer. So your hard drive does not require power to hold its memory, whereas the RAM does. Right? So another reason to use files is that we may want persistent data. We may want to leave our data without it disappearing. Right? So it's not only the case that we use files because they're huge. We also use files because they're persistent. In any case, let's go back to this. So they want us to write an error and an explanation of the error if one is thrown, and leave blank things blank. So what gets printed here? Right? This is very much like what I do in lecture. So if I set a string s1 to abc, and then I set a string 2 to s1, and then I set s2 to xyz, what is the value of s1 when printed? Well, what are the two options for s1, right? We're clearly trying to trick you using some type of pointer, right? So it can either be abc or xyz. Well, who wants to hazard a guess? Yeah. You think S1 is XYZ. Okay, let's check. So what was it? X is ABC. Y is X. Y is, what was it? XYZ. And now we're asking for the value of X. I think it's going to be ABC, but yeah, ABC. These aren't lists. Strings and lists are different. Strings are immutable, right? So they don't get pointers. Like you can treat them like a constant. And so you don't really have a pointer to a string. You really just have that string in memory. So then what should the value of y be? That's easier. X, Y, Z. Okay, so this is ABC and this is X, Y, Z. Let's check. ABC, X, Y, Z. Perfect. Oh, let's look at the marking scheme. 1 point for correctness. Right? Well, okay. Maybe it would give you half a point for each, even though I despise half points. I'd rather just double the marks of the test, right? That's my favorite question, by the way, when students are like, how much is the test out of? I'm like, well, ultimately out of 100, because you get a percentage, but originally 10,000, right? I'm going to give you 10 multiple choice questions, each worth 1,000 marks. Then they slowly begin that the question doesn't make any sense, right? So, anyways, if any of you are ever professors, you can play these kind of tricks. Part B, if I set S1 to the string ABC, and then set S2 to the string S1, and then in S1 replace all instances of C with Z, what is in... Oh, okay, so first of all, what gets printed if I replace C with Z in S1? Okay, so let me see what's at the end here. Okay, so if we ask you to use a built-in, we actually are going to give you a list. Okay, I can 80% confirm this. Ask Vincent to absolutely confirm this, but I'm pretty sure, because all the midterms and tests have included this page, of all the built-in operations, right? So if we're going to ask you to use a built-in, it's most likely the case that we're going to tell you exactly what it does, which is not that much of a cheat sheet because you also have to be able to read the documentation, which itself requires you understand computer science, right? So they're back there. So let's look at this replace to see what it does. Return a copy of S with all occurrences of the string old replaced with the string new, and it returns a string, right? So I imagine that we're going to have to return something. So the replace is actually going to return a string, it would seem. Well, let's just check that. X dot replace the C with Z. Okay, so it did return something. And I knew that from the return type. Okay, so we learned something. For once. Okay, so what does S1 dot replace print? That's going to, yeah, A, B, Z. If I print out S1, that should give me A, B, Z again. If I try to set the first letter of S2 to X, they're immutable. Error. Right? This won't work. If I then print S1, I'm going to get ABZ, and if I print S2, I'm going to get ABC, right? Because these strings are immutable, right? So these are not pointers, right? We're trying to trick you with lists. Okay, let's see if we got this right. Okay, replace prints ABZ, S1 prints ABC. Wait, is that what we said? No. Right, because we didn't assign. Okay, good, we learned something. Yeah, so this isn't actually changing the value of S1. It's not like append, right? It's creating a new string, right? Because remember, strings are immutable, so whenever we make a change to a new string is made. So that's why that goes to ABZ. That's why S1 stays the same as ABC. That we were right. Well, I don't know why these are blank. There definitely should be. Oh, I guess maybe since an error is thrown, the rest doesn't actually execute. I think that was specified in the question, though, right? If the code would cause an error, write error, provide a brief explanation, and leave any ladder spaces in that sub-question blank, right? So the question, in fact, told you, stop working after you've thrown an error. So just be double, yes?
So S1 replace is its own string, right? As opposed to S1.
Well, S1 dot replace is a function which returns a string, right? So this has return type string, right? Whereas the list operations didn't have return types, right? They just changed the string in place. Part C. Question. Lists now, right? So now we're moving from immutable strings to lists and their list pointers. So if I make a list, then this list I'll have a length 3 list comprised of the characters A, B, C, and I make L2 equal to L1, and I append 4 to L1. Well, okay, so first of all, does anything get printed? Let's check. So let's look for append. Append. Returns none. So nothing's going to get returned. Okay, so the answer to this is nothing. If I print L1, that should give me A, B, C, 4. The number, not the string. So it would be incorrect to say 4. For YouTube, I'm air quoting. Right? So not air quotes 4, but 4, the constant. What happens if I change the 0 position in L2 to a 1? Well, is it going to print anything, is the first question. Is that true? Oh, that was a string. Okay, it doesn't print anything. Okay, so that doesn't print anything. But what is L1 here then? So I think it's 1A, B. It's 1B, C, 4. And then L2 should be the same thing. So let's check. Okay. So we had L1 is equal to A, B, C. What was the first thing we did? L2 is equal to L1. L1 dot append 4 doesn't do anything. L2 of 0 gets 1. L1 we said should be 1 BC4. And L2 should be the same thing. Great. Okay. Part D. S is an empty character. For character in this list of characters, if character is an upper character, accumulate on S. Print S. So what? Huh?
Okay.
Let's check. Upper is upper. Return true if and only if all cases in the characters are uppercase. Now you do. Just make sure to read the last page if there's any. Where was I? Part E? Where was I, anyone? Oh, part D. It's not time for a party until after your test tonight. Okay, so if I set S to the empty string, and I loop through some characters in CSC 108 at UTM, so what is this going to return? What am I accumulating here, it seems? Well, we're accumulating on S, but what is S accumulating? Yeah, but which ones? Yes, and we're accumulating to the end. So this should print out all of the uppercase characters without spaces. So this should print CSC UTM. Everyone agree?
Yeah.
Damn it. Okay, yeah, we have to be careful with these nuances, right? I didn't read the question close enough. There was a print in there, and it's asking us, please learn from my mistakes, right? Read the question carefully and answer the question. So, yeah, we would have just tossed away a free mark. Okay, so yeah, you have to print out every step of the accumulation, right? C, CS, CSC, CSU, CS, CUT, CSC, UTM. So I should have read the question more carefully. Part E. S is the string CSC 108, your course code. Your index is equal to the length of S, which is what in this case? 6. So index gets 6. While the index is greater than 0, decrement the index by 1 and print S at the index. So what does this do? Well, let's just, so what gets printed first? S at index what? So I walk into this while loop with index set to 6. The first thing that happens is index gets set to 5, right? And then we print S at 5, which is what? An 8. And then I think the next thing we're going to print is a 0, right? An 8, then a 0 on the next line, then a 1, then a C, then an S, then a C. Yeah, there's a print in there. Yeah.
It would print the last one.
Would it not print the last one? You're correct, it won't print the last one. So it'll print backwards per line, one character excluding C. Okay.
Won't it print the last one? Because if index is 1, it's greater than 0, then it goes down to 0.
Wait, he's right. Right. So this will print the last one because, yeah, the last thing index is allowed to be is 1, and the first thing we do to index is decrement it by 1. So indeed, we do have 0. Right, so this will print all the characters backwards on new lines, all of them. Yes, there we go. Question 3. That's the answer. Let's look at the question. Well, that's a little bit long. This question uses the terminology from assignment 1 of that year. Recall that a course record is a string composed of a 3-character course code, a 2-digit course mark, and a 2-digit exam mark separated by commas. Recall also that a student's final mark is the average of their course in exam marks unless they have an NE exam mark. If the student's mark is NE, then their final mark is their course mark if they are a special case. If they are not, then NE is treated as a 0. For the purposes of this question, a student has failed the course if their final mark is less than 50%. So we want to create a function has failed, which takes a string and a bool, and returns true if and only if the course record has a failing final mark. Complete the docstring above, providing 4 examples that represent distinct cases. So maybe this is a bad one because we didn't do that assignment. So let's just skip to question 4. A binary string, but I'd like to mention that we've already done more than half the test. Right? This is the last question on the midterm, right? So it's not that hard. Right? I'm pretty sure most of you can do this in the 50 minutes required. A binary string is, these are the things that you hate, right? But a binary string is a string composed only of the binary digits 0 and 1. Each character in the string represents a single bit. This question asks you to write a function that implements a binary operation. Bitwise, so this is a new operation, exclusive OR. For 2 binary strings, the bitwise XOR is computed by performing XOR on each pair of bits that have the same index. So exclusive OR is OR, which excludes the one which both are true. Right? It needs to be exclusively the case that one is true or the other is true, but not both. Right? So that's what it says here. So exclusive OR of 0 is 0. Exclusive OR of 0 and 1 is 1. Exclusive OR of 1 and 0 is 1, and exclusive OR of 1 and 1 is 0. So we need to return the bitwise XOR of the 2 binary strings. Okay, so we basically just have to like pull in 2 strings and then walk through the string and build a new one, depending on the if it's 1 and a 1 or a 1 and a 0 and so on. Right, so this gives you a 0. So do you understand what we're doing here? Do you know how we add? Like I say 1, 2, 3. Plus 45. Right, I can say this is 8, this is a 6, this is a 1. I can do the same thing, 1, 0, 1, 0, 1, 0. And I can put and here. Right? I can do the same thing. 1, true and false is 0, 0, 0. Right, so I'm going to do this now with XOR. Right, exclusive OR. Okay, so 1 exclusive OR 0 is 1. 0 exclusive OR 1 is 1. 1 exclusive OR 1 is 0. Right, so basically this is what the function is asking us to do. Build a function which takes in this and this and returns this. But it should be easy. We just need to look at every position and build the answer. Right? So, huh? Yeah, 0 XOR 0 is 0, right? So we need 4 rules. We need to know what 0 and 0 goes to, 1 and 0, 0 and 1, and 1 and 1. Okay. So let's just write this. Definition string XOR. I think that's what it was called. We're going to take one string and another string, and we're going to return a string. I think I should be doing that, actually. Whoops. So what were our docstring examples? I'll just put a couple of them in here. I'll do the one I did on the board. So the string XOR of 101 and 110, that should be 0, 1, 1. Okay. So how can we do this? Right? We have to like walk through a string and look at the 2 other strings. Right, so let me do this. I'm going to say 4k in the range of the length of one of the strings. We're assuming that the string lengths are equal when they come in. Could I make that assumption? Where does it say that the strings are? Oh, you may assume that the 2 string arguments will have the same length. All right, so I'm just going to put that here. Assume length of S1 is equal to the length of S2. Okay, so I want to look at every character of this. So I want to build an answer, right, from nothing, the empty string. Eventually I want to return this answer. So what do I want to build here, right? So I can pull out the kth member of S1 and the kth member of S2, right? So I just have to act on these. Yeah. What was your idea?
Check if they're equal.
Sure, you can do that. So if they're equal, yeah, but then we have to then break that case into two further cases. Because it could be equal in both zeros and equal in both 1. Oh, but in both those cases, you're correct. Okay, so if they're equal, I accumulate, I heard it, 0. Okay, so otherwise, what's the other case? Yeah, I'll do an else. L if L if S1K is in. Yeah, wait. Else. Else. Just make 1. Good job, guys. Yeah, so there's really only 2 cases. If they're both equal, then it's 0. Otherwise, it's 1. So that was good. I was going to make 4 cases, but this is better. Let's see if this works. Whoops. Well, that's always an option. Bitwise. Oh, sorry, you guys can't see. Bitwise. What? What was my function called? String XOR. That's right. That's right. Great. That's right as well. So that worked. Good job. And that would be the end of the test. Right. It's not bad. It's not bad. Well, we did skip one of the questions, but let's assume that if we had done that assignment, that it wouldn't be, because they did another test with the other class, and we did it in a half hour, right? But I think it's unfair. Well, yeah, because this assumes a lot of stuff from assignment 1, which we didn't do. So how much time do we got? We still have some more time. Let's do another one. I remind you, they can leave if you want, right? Which one do we do? 2016. Do you want to do 2017 or 2014? 2017 or 2014? 17. Okay, so another midterm. Let's see how far we can get on this one. So every time I see pizza now, I read that in my head as piazza. Does that happen to anyone else? Right? Okay, so I set x to pizza. I set y equals to x. I set x is equal to x plus x. What's the value of x? Yeah, call pizza pizza. With or without quotes around it? With quotes, because it's a string and we're not printing something. Quotes disappear when we print. What's the value of y? Pizza, single pizza. Yeah. Let me just check out the solution here. Yep, pizza, pizza, and pizza. Okay. Now I'm changing this question to use list. So x gets set to the singleton list pizza. So it's a list of length 1 with 1 string in it. I set y is equal to x. I say x is equal to x plus x. What's x? You can concatenate lists using plus. Right? So that plus in this case is list concatenation. So given that it's list concatenation, what's the answer here? Huh? No, but say it properly. Yes, it's a list of length 2, and the elements of that length 2 list are pizza, comma, pizza. Okay, that one was easy. What's y now? You say single list pizza. Who else says single list pizza? You say single. You say single. The answer. Okay, let's look this up. What was the name again? Pizza. Okay. This is really important, actually, because I didn't know this, or I got this question wrong. So y equals x. X is equal to x plus x. And since this is doing, oh no, this is an assignment, so it won't print anything. right? Remember, nothing gets printed when you're assigning. Okay, so this should be pizza, comma, pizza. Okay? So now I'm asking, what is y? So we had some guesses. We're having people saying it's pizza, pizza, and other ones saying it's pizza. So let's investigate this and see if we can suss it out. So pizza, x gets assigned a pointer to the list pizza. Then y gets assigned that same pointer. Then x gets a new pointer, which is pointing to the list concatenation of two things. So at this point, x is no longer pointing at the original list. Right? So actually, the answer to this question is single pizza. So there's a nuance here that you guys should try and understand. Right? I answered pizza, pizza for this. I would have got this question wrong on the test. Right? So it was deliberately put in here. Like we're trying as professors to find like all these crazy edge cases that I even wouldn't know how they operate. But
You don't need to use a pen.
huh? You don't need to use a pen. You can use a pen if you want, but in this question we used concatenation. Right?
I thought that didn't work.
Plus clearly works. I just typed it into the compiler, right? So that should be enough evidence there, right? Okay, so let's try to draw a picture, right? So the first thing we said is x. Okay, so x points to pizza, and then what do we say? We then say y is equal to x, which basically means I get a duplicate of this pointer. And then I'm saying x gets x plus x, right? Which means that x has to create a new pointer to like a list of two things. I don't even know how to draw this. Yeah, I don't even know how to draw this. You just have to sort of. It's hard to draw what the pointers are going because I want to draw a pointer back into itself. Yeah.
If instead of just adding it was a pen, would it still create a new pointer?
You want to try? Yeah. So let's try this again, but we'll use pointers. So y equals x. And then what do you want me to append to x? Pizza? Yeah, now I think we're going to get the behavior that we expect. So x is now this, and y is now this, right? Because that list, when we're using a built-in, it's actually like affecting that list in place. Whereas we're using these higher level operations, like new pointers are going to get created. But this is a weird nuance that I don't really know how to explain sufficiently clearly. But just know that there's a difference between using append and using plus, a severe one. Any questions back there? No? All right. Where were we? One more and I'll kick you guys out. What is this? It's the solutions. Also solutions. Oh, here we go. Okay, x gets set to pizza. Oh, let's skip these ones. Let's do a question. Complete the function below according to its docstring. Definition sorted. Takes the L, which is a list of integers. Return true if and only if the integers in L are in numeric order. So minus 3, 0, then 3 is sorted. And minus 3, 0, minus 1 is not sorted. This is interesting. How would you do this? It's going to start typing into the thing here. But think, how would you do this? If I gave this to you on a test, which has clearly happened before. Any ideas? Allowed to use, well, because you're allowed to use the comparison operators, you're implicitly using order. So sure, but using order is not necessary. Like don't compare the orders of characters because you can just compare them using the less than operator naturally. Like if you want to compare the ordinal of A with the ordinal of B, right? This is going to be the same as just doing this directly. So what do we need to check? We need to check that every position is followed by something that's at least bigger than the thing before it. All right, so I'm going to walk through this list using an index, right? Because I need an index because I need to say here and the next thing. So for k in the range of the length of L, what do I want to ensure? So I'm going to return if I find false, and then I'm going to return true if it never flags a false. So if it's the case that the position at k is greater than the position at k plus 1, then I should return false, yeah? Okay, but what do I have to do to fix this now?
You have to do like a -1 on the length.
Yeah. I can't go to the end of the list because that would be checking the front, right? I'd walk off the end of the list, so I just have to stop at the end. Let's see if this works. Name list is not defined. Oh, right. Great. Great. Cool. That one was pretty easy, actually. How much was that worth? 4 marks that was worth. And it was like 2 lines of code. 1, 2, yeah. 3 lines of code, including the return. So that should be okay. What else do we have here? All right, go enjoy your Friday. I know some of you have some tests. Have a good weekend.